Sake of the people. For the sake of the people at home, right? We're working with coffee shops, Lyon and Roaster. They're competing with each other to get the business of customers, right? And at Lyon, a cup of coffee costs $2.25. So we figured that the equation y equals 2.25 times x is the cost of x cups of coffee, if y is the cost, right? Now, there's a discount program here that says if I buy an $8 mug, I get all of my coffee $1 off. All of my cups of coffee are $1 off. So, Oliver, what's the equation that you came up with that describes what the cost of X cups of coffee would be now?
I 0.25x plus 8.
I'm hearing y equals 1.25x plus 8. And this kind of makes sense, right? 1.25x is the cost of X cups of coffee, but then you also need to add in the $8 mug, right? Let's graph each of these. Let's graph the first one in red, and let's graph the second one in blue. Okay, let's do the red one first. Do you have any data points here for the red equation for the 2.25x? Where's my y-intercept, for example? Yeah, okay, so, or rather 0, 0, right? 0, 0, because remember my x-intercept or my y-intercept is a point. So 0, 0. And then how much does it cost for 4 cups of coffee with this, without a $9, right? So 9 times 2.25 is 4, or 9 times 4, sorry, 2.25 times 4 is 9. Is it? That doesn't sound right. Hang on. For $4, 2.25? Yes, it does, right? 2.25. $2.25. $2.25 times 4 is 9. Okay, here we go. Right? What about for 8 cups of coffee? Right, makes sense, right? We're just doubling it up to 18. So 18 is over here, and I've got 8 cups of coffee here. Okay? So I'll draw a line. And if you don't draw a line, I'm not gonna mark this wrong if this was on a quiz, but I think you should draw a line because we are talking about lines. Okay. For the blue equation, what's the x-intercept, or sorry, the y-intercept there? It's 0, 8. Thank you. It's 0, 8. So it's gonna be right here, 0, 8, right? There it is. And then the slope this time is 1.25, which is 5/4, right? So I'm just going to go up 5 over 4. So it looks like maybe 4 cups of coffee would cost 13. Does everyone agree with that? $13 for 4 cups of coffee and if you have the club membership. Okay, and then for another 4, maybe it'd be, another 18. So it'd be like there, right? So it looks like my graph is going to look something like this. Okay, nice. All right, thanks, Oliver. So, Otis, looking at this, right? If Sarah only wants to buy 6 cups, right? Maybe she's only got like one event. Should she get the membership or not? She should not. Looks like it, right? And how'd you know that?
Six.
Ah, replace X with 6, right? So let's do that with both equations. Let's do that with the red. 2.25 times 6. Can anyone tell me what that is? So I'm just going to write this down. So the red is with no club, and the blue is with yes club. And what did you say? Sorry, Otis, I didn't hear you. $13.50. What about for blue? With a cup. Yeah, it's like 15.50, right? We got that by taking 1.25 times 6 plus 8. It's more expensive if you get the cup, right? You get the mug. Can you see on the graph And also just tell from the information, what's the break-even point? What point is it actually like the same? Yeah, $18 for 8 cups of coffee. Very good. 8 cups for $18. And we can see that right here, right? This is 8 comma 18. That's the break-even point. You guys know what I mean by break-even, right? Yeah. Okay. So how many cups of coffee, Kara, will we need to actually get a better deal? Anything above that, right? 9 or more, let's say. 9 or more cups. Sweet. Someone raise your hand. Did you raise your hand?
No, I'm kidding.
Okay. That sounds more pretty much logical, I hope. Okay. Move on to the next page. Let's go again. Let's go through the first thing and then I'll leave you guys to it. So now we've got the other restaurant, Roaster Coffee. Yeah. Their regular cost for a cup of Joe is $2.50. Okay, so a little more expensive. However, they're doing the same thing. They're doing a mug club thing, right? If you join the mug club for $10, you get half off your coffee. So this time, how much does it cost to get X cups of coffee for their club? They have a different club. Okay. It's going to look somewhat like this, right? It's going to look someone like the Leon Coffee Club equation, but it has a different cost. Can anyone see how it's going to be different? Kara, can you see how it's going to be different at all?
Yeah.
Right. So how do I adjust the equation then? 1.25x, but this time it's plus 10 instead of plus 8. And that kind of represents the fact that like joining the club is a little more expensive for this place. Right? Let's hope they have better coffee. Okay. Awesome. Now, starting with B, it wants you to start comparing the two restaurants. Instead of comparing club or no club, this time compare the two restaurants and their clubs. Okay? Jack, I have you on deck. In a couple of minutes, can I ask you about B and C here? Or actually about B, let's say. Mia, can I ask you to talk to me about part C here? Like for graphing those two equations. So you have the two equations, just graph them, right? And then, Bodhi, can I ask you about question 3 in a second? Okay, so talk to your team, to your table about tackling this question. Okay. And then after that, Davis, I'll ask you about you and your table about 4. Okay. Okay. So let's just keep going. Keep going with it. I feel like
The starting price.
Leon Coffee. I mean, I think that they'd better have better coffee. All right, I'm going to pause this recording just so that the people at home can fast forward. Okay, so now we're saying that Lindsay plans on purchasing 10 cups of coffee. 10 cups of coffee, yeah? Which mug club should she join if you're thinking of you're only going to drink 10 times? Leon, why?
Cost $2 if 50 cents, and it only costs $20.
Okay, so you're saying that Leon is going to cost $20.50. Let's just really quickly make sure we see how you got those numbers. Leon, you got 125 times 10 plus 10, right? And that was what? $22? 22?
Oh yeah.
Oh, sorry, this was for a roaster. This is the more expensive one. This is for
Yeah,
roaster.
that's-
Oh my God, dude. Yeah, this is for R. 22.50. Meanwhile, Leon is a little cheaper. 125 times 10. This time it's plus 8 for $20.50. Is that what you got? Yeah. Note that they're both charging $1.25 for their each cup of coffee once you've joined the club, right? Okay, and then Mia, what are your two equations? What are the two lines looking like? Can you describe maybe where to start and like where to go? You don't know? That's okay. Let's just do it from here then. We've got like an equation that looks like y equals mx plus b. Right? So where's the y-intercept for this one here representing our roaster coffee? What's our y-intercept? Yeah, 10, right? Or 0, 10. Just gonna start here. And then how much is it gonna cost for like 4 cups of coffee here? What's our slope? Right, 1.25, which I'll note is actually equal to 5 over 4. So let's rise 5 and run 4. Right, 5 over 4 is 1.25. So let's rise 5 and run 4. Rise 5, run 4. $15 for 4 cups of coffee. Rise 5, run 4. $20 for 8 cups of coffee. Oh, geez. Okay, that's better. Okay, so that's for roasters. Meanwhile, the one for Lyon, we already have that graph. See? We have it already. It's just here. It's just there in blue. Right? So let's just copy that one. Cool? So we already did the work, so no need to do the work again. Here's the one for blue. Oops. Here. This is for Lyon. Okay, do you have that down? Mia, do you have that down? All right. Modi, looking at those two graphs, where are they going to be equal? Never. Modi says never, and why not? Yeah. Right, exactly. Right. The mug costs 2 more for roaster. And how does that how is that manifesting on the graph? Parallel. You used a great word, parallel. The lines are parallel, which means they never intersect, they never cross. The lines never cross, right? Which means they're parallel. If you remember that from geometry, the word. Okay? There's no break-even point. And that kind of makes sense because Roasters is charging $2 extra for their membership. Okay? Finally, Davis, you and your table. It says here that Roaster realizes, oh, they kind of made a mistake here, right? So they changed the promo to get for only $8 now. And still they're doing half off their coffee. Right? So now which mug club should Lindsay join? She's only buying 10. She's only buying 10. Huh? Yeah, David's telling me that the cost of $10 mugs of coffee for both of them is going to be the same because now they're just charging exactly the same for their membership. Yeah.
Roaster one's a better deal though, because the starting price is higher than the only starting price.
Ah, you're thinking that Roaster is a better deal because their starting price is higher, and so maybe they're like making better coffee or charging like their premium is a little bit better. Maybe. But when we're talking about just the cost, like after getting the membership, they're actually the same, right? So they're the same. 10 cups costs $2 and 20.50 for both. And in fact, for how many cups of coffee will the total cost for each plan be the same now? All of them. It's the same plan now. It's the same plan, right? Right? It's the same plan now. Okay? All right, shall we continue or is anyone still writing that down? I can give you a couple of seconds now to just write all that down. Let me pause the recording again. All right, let's finish this up. Okay? So to recap some vocabulary for you guys, right? A solution to an equation is just a choice of the variables that make the equation what? True, right? It just makes the equation true. And if you have a system of equations, that is just more than one equation, then a solution to a system is just a choice of variables that makes all of those equations true, right? Here, for example, here's a system of equations, and here we graphed them. When you graph a system of equations, where does the solution show up on the graph? Yeah. Yes, you can use the bathroom. Where does the solution show up on the graph though? Yeah. Where they cross, where they intersect, right? So what we're saying is that this point here makes both of these equations true, right? If I plug in x equals the first number, y equals the second number, then both of these equations are true. What point makes both of these equations true? So now we've got this equation here, written here in red, and this blue one from the previous page. Is both of these equations true, Tachi? Nowhere, which means that there are no solutions to this system. Okay? After they change their promo, their line shifts down. So after they change their promo, both lines look like that. Not a very good drawing, but you get the point. Where are both equations true now? Yeah, everywhere. How many solutions are there? An infinite number of solutions, okay? So when you are asked, if you come across a system of equations out in the wild, let's say, you might just be asked not to find the actual solutions, although you can. You might just be asked, wait, how many solutions does this even have? Okay? And the easiest way to do that is to look at this flow chart, right? If they have different slopes, like we had up here, if they have different slopes, they have to cross somewhere, right? I challenge you to draw two straight lines with different slopes that never cross. I don't think you can. Okay? I challenge you. So if they've got different slopes, they've got to cross somewhere, like these two. Okay? If the two lines have the same slope, then there's only two possibilities. Right? Either they run in parallel forever or they're the same line. Okay, so that's how you narrow it down. Is all making sense? Okay. So here we had infinite solutions. I'll write this down. You can use this symbol here, infinite solutions. The infinity symbol. This one here had 0 solutions, none solutions. This one has 1 solution. Is it possible for a system of equation to have like maybe 2 solutions only? Can you think of a situations where a system of equations have 2 solutions exactly? A line and a parabola. There's a solution, there's a solution. Yeah, right? But for now, we're not yet working with parabolas. That'll come a couple of units from now. But yeah. When you're only working with lines, when they're only working with straight lines, there's only those 3 possibilities, okay? Second thing I want to show you is just a little bit of vocabulary. I know I'm expositing a lot, okay? I apologize. What does expositing mean? So, yeah, exposition, right? Like, have you ever like read or typed up a story and just like, oh, show don't tell, right? Yeah. Don't be like, don't just say, oh, this is thing about the world. You have to like show that it's true. Okay. Here's a bit of vocabulary for you guys. This vocabulary, it's not going to be on the test. We're not going to ask you to like memorize this word, but if the word shows up, you should know what it means. Okay? Does that make sense? That's what not assessed means. A system of equations, if it has a solution, at least one solution, it's called consistent. It's called consistent. Okay? Meanwhile, if it has no solutions, it's inconsistent. So looking at these three like situations up here, situationships, which ones are consistent and which ones are inconsistent? Yeah.
The first one is consistent.
It looks like this first one is consistent, right? Because it's got a solution, right? There it is. What about this one, the one in the middle? This is inconsistent, yeah. And then what about this one? This one where like it's just the same line on top of itself. That's consistent as well. Right? Because here you've got all of these solutions. Okay? Another word that sometimes gets used instead of inconsistent, and I don't really think we're going to see this very much, is that instead of inconsistent, you might call it degenerate. Degen. It's a total degen system.
Because the other one.
If there is, I actually don't know it, so let's not worry about it. I can't think of one off the top of my head. Consistent. It's got answers, huh? Regenerate. I don't know. Regenerate. I don't think so. I don't think so. Okay. That's all this. That's all the instruction for today. Okay, we're back. So, Logan, what did you get for 1A again? You got a one solution, and why one solution? Yes. And that's all you needed to see, right? One solution, different slopes. Nice. Okay. Really easy. What about part B, Touchy? Did you have one solution, infinite, or zero? You had zero. Why zero? Okay, if I take the top equation, I'm just going to rewrite it. 15x minus 3y equals 6. What did you do to the top equation? You added 15x to both sides. So you got negative 3y equals 15x plus 6. And then what? You divided both sides by minus 3. Y equals negative 5x minus 2. We compare that with the other one and we see that we have the same slope. But what else? Yes. Right. They're the same slope. They're minus 5. So down 5 over 1. But one has a minus 6. 0 minus 6 is a y-intercept. The other has 0 minus 2. So they're going to look something like this. It's a pretty crappy drawing, but it doesn't matter, right? They're going to be parallel, but they don't have the same y-intercept. They've got to have no solution. So 0 solutions. Good. Okay. For Nora, what was your argument here? Question 2, common Ashmita, sorry. We're given a portion of the graph, two linear functions, right? Is it consistent or inconsistent? Pam says inconsistent. Ashmita says consistent. Who's right? What do you think?
The lines don't have the same slope.
Yeah, they have different slopes. Yeah. You can see, right? This one has a slope of a third, 1 over 3, and this one has a slope of 1 over 1, which is just 1. Okay, and so they're going to intersect, maybe up here somewhere, right? Just because we can't see the intersection doesn't mean that they're not going to intersect eventually, okay? In this class in math, we're concerned about the global picture, okay? Maybe in like some contexts, right? Maybe if we were like modeling two things like in real life, maybe we wouldn't actually be able to go out that far. Maybe like it would be too much cost or like time doesn't go out. We're not actually predicting that far into the future. But here, yes, they do eventually intersect, and so it is consistent. Finally, 3. This is the hard one. Here's a system. 3x minus 4y equals 10. 9x minus 12y equals b. Okay. Gwendolyn's table, did you come up with a way to find what b would have to be for these two to be the same line? Talk me through it. Don't just give me the answer, but like talk me through it. So 3x minus 4y equals 10. You wrote the equation again. What did you do to that equation? You isolated y. Okay, sure. Uh-huh. And then what? Uh-huh.
Negative, yeah, negative 3x plus 10.
Sure.
That's by
Negative 4. You divide both sides by negative 4 to get. Uh-huh. Minus 2.5. That's fine. Okay, but then how does it help us find b though?
minus 12y.
I see you took 9x minus 12y equals b, and then you did the same thing to convert, and let's see if I can do this in my head. You converted that into 3 over 4x, minus b over 12, right? That's what you did? So if b equals 30, so if b equaled 30, you got that b over 12 is negative 2.5. And so therefore they would have the same y-intercept, and they'd have the same, they'd be the same line. That's a pretty great way of doing it. I think that that's totally fine. You converted it into y slope intercept form, which is the form you're most familiar with. We're all most familiar with y equals mx plus b. I think there was a slightly easier way of doing it. So this is fine, and it's recorded for posterity. But I see Riva with her hand up. Did you have a different way of doing it? Ah, that is the easier way. Yes, right? Look, and I think this is worth like kind of noting in your head. If I multiply both sides of an equation by 3, does that change what the solutions will be? No, right? If it was true before, if a value made it true before, it'll make it true after you multiply it by 3 as well. Okay? So all I have to do is take both sides of this equation and multiply by 3. This gives me 9x minus 4y, sorry, minus 12y equals 30. And you can see that this equation matches this equation, except that b is instead 30. So therefore, if that b was a 30, these two equations would give you the same line. They would be the same equation, essentially. Yeah. You kind of just have to look at it. Yeah. How do you know to multiply by 3? You can just kind of notice that the left sides of the equations are the same, except this one is the other one times 3. Will it always be so clean? No, no. So there are other tools, yeah. So I think the way that you did it is like kind of more consistent, right? Like it kind of always will show you, right? But being familiar with this form of the equation, looking at this and being able to tell, oh, those have the same slope, right? Remember, our slope is going to be this guy divided by this guy. Or sorry, other way around, right? Our slope is going to be 3 divided by negative 4, which is what you found. Or negative 3 divided by 4, by negative 4. Right? So these two coefficients will determine your slope. So looking at that, you can be like, oh, wait, those are going to have the same slope. So what does that have to be same thing? It's a little weird and abstract. The process is not always consistent, okay? As long as the logic holds, you're fine. And the logic holds here. Okay? Guys, where's the homework? Normally, yeah, it's in the normal place. It's in your packet. Same as everything. I just didn't put it in the assignment center yet. I will put them in now. like imminently. Okay. For now, go get some lunch. I'll see you soon.